you're running Kubernetes in production, you probably scan images and fix CVs. But two questions usually get missed. Is my cluster actually secured? And if attacker gets access to my cluster, what will happen? I'm Anjali Shukla, founder of Container Security Village and lead of OWASP EKS Code project. In this video, I'm going to discuss Kube-Bench and Kube-Hunter, two important tools that are a solution of these questions. So we'll start with creating vulnerable workload on Kubernetes, and then we'll scan it using Kube-Bench and Kube-Hunter and see the differences between the output of two, and when should we use the Kube-Hunter and when should we use the Kube-Bench. So let's get started. So this is a killer coda where I have deployed these two labs, Kube-Bench and Kube-Hunter. We'll use it for this demo. And before starting, I would like to show GitHub repo for Kube-Bench and Kube-Hunter. So this is a GitHub repo for Kube-Bench, again an open source tool by Aqua Security. And it is used whenever we have to do the benchmarking based on the CIS. And it is really helpful in doing auditing. Generally, a CIS report is asked, so you can show the report of Kube-Bench because it is based on the CIS benchmarking. And second, we have a tool called Kube-Hunter. So this is more like an enumeration tool when we are doing a Kubernetes assessment and would like to start with. For the auditing purpose, we'll use the Kube-Hunter tool. So let's start today's scenario. So first of all, we'll deploy the insecure workloads. And for that, I will start with creating a namespace. Cluster is already running, so you do not have to worry about that. So let me create a namespace with name kb-kh lab. And now I will deploy this insecure deployment, which is, if you will notice, here I have added a security context privileged true. Means if attacker get access to my pod, the pod will be running as a privileged pod. Allow privilege escalation is also true, and run as user means that the pod will be running as a root user, so that is also true. Along with that, I am mounting a host/etc directory with my pod, which is also insecure. So let me check the status of my pod. It is successfully running. So these are the misconfigurations that we have added, and these are the dangerous one. We'll see if our Kube-Bench and Kube-Hunter able to find these misconfiguration and what kind of a output we'll get. So we'll start with the Kube-Hunter, which is a auditing tool that we use to see what are the exploitable or the initial attack surfaces as an attacker. So we'll start with we'll get the manifest for Kube-Hunter, and deployment is really easy. We'll get the manifest and then apply that manifest, the YAML file, and it will run as a job. So job in Kubernetes means it's a one-time activity like your cron job, and the pod of Kube-Hunter will run, scan your environment, and then exit. So that is a one-time thing. So our job is created, and this small automation I have written just to get the status of that pod if it's running, and also the job is completed or not. So basically the scanning by the Kube-Hunter is completed or not. So let me just run that. It will wait in case the job is still going on, and if you can notice, I have added a sleep of 5 seconds as well. So the job is completed. Now it is fetching the logs for me. I will get all my findings in log of that particular pod. So I'll get the pod name and will fetch the logs. Now, if you can notice, the output is coming in a really nice table, a human readable form. And it is giving me information like this is the API server location and what is the location of this particular finding, what is the MITRE category, vulnerability, a small description and evidence as well. So I am getting that there is a lateral movement, and this capability, which is a cap net raw, it is enabled. Okay. The another finding I have that secrets or the sensitive interfaces are exposed. So I think it is exposing the version. As you can see, it is exposing the Kubernetes version, which is 1.34.1. And similarly, I have other output as well. And in the evidence part also, it is giving me the evidence that where it found that particular information. So it is saying that it is able to access the service account token, and this is the evidence for it. This is the location for that particular service account token. So these kind of findings I'm getting using Kube-Hunter. Let's say if I have to get the log based on the vulnerability or found vulnerability kind of a thing, then again I'm reading a log and just grabbing that particular keyword, found vulnerability. So I will just have the output which is having vulnerability. So I'm getting all the information from this output, that what is the severity, what is the location, basically what is the evidence where I can find it. All the relevant information I'm getting in this log, and that too in a table format. So from the findings, if you check, I have these 4 major findings. Service account token is mounted. Capability, which is a net raw, it is enabled. Able to access the pod secret, which is a default service account. And API server accessibility. Okay. So now, as of now, I ran the job with the default service account, a normal user with default permissions. Now I will see what will happen if I run the same scan, but this time with admin permissions. So for that, I will create a service account and I will create a role. So this is a cluster role I'm creating, and in the rules section, you will find that API group, resources and verb, and keeping it as a star means everything is allowed. I'm binding it. This is the role I've created, and I'm binding this with above service account, which is Kube-Hunter SA. So now here you can see this is a cluster role binding. I am binding it with Kube-Hunter SA. That is the name of my service account. Now let's create another job and get the output in a JSON format. So I will just delete the previous job and run my new job. So it will do the same thing. It will first of all check if the pod, that particular job, is into the running state, if it is fetching the logs or the job is completed or not. If the job is not completed, it will wait for 5 seconds and then again check the status of it. So as you can see, it is still in running mode. It is fetching the logs for me. So I'll wait for 5 to 10 more seconds. And now the conditions met. So let's quickly check our data. So this time I'm getting the data in a JSON format, because here I have attached this JQ, like I'm reading the logs and then getting the, so as all the logs are coming in a first line, so I'm just getting tail -1 and then JQ just to get the output in a pretty good format. So these are the findings I have. I have access to the Kubernetes API server I got in the admin permissions. Let's see what else I got. It is giving me that cluster role might give an attacker a valuable information. So these are the findings we got. Don't worry, I'll do the comparison as well, that what are the findings I got in case of a default service account and in case of an admin service account. So next I will do the comparison. So default versus admin. So now if you can see, in case of a default, it is not able to detect the insecure Nginx pod. However, in case of an admin, it is able to detect that. Also, it is not able to list the pod in other namespaces in case of a default, because as it is a default service account, so it has permissions of only default namespace. However, insecure Nginx pod I have created in a different namespace, which was kh-lab namespace, the initially that I have created. So it was able to get that finding only in case of a admin. So similarly, I have this difference, like comparison table created. So these are the findings that I'm getting in case of a default service account. Capability, exposed pods, running pods, kubelet, command lines, and etc. Let's see what are the findings I have in case of a admin service account. So these are the additional one I think I'm getting. Listing namespaces using admin service account. This version disclosure I already have. So these are the main that I have in case of a admin service account. So also I've added the comparison in this theoretical format as well. You can validate as well on the terminal. This was it in case of a Kube-Hunter. Now we'll see what different output we'll get in case of a Kube-Bench. Remember, Kube-Hunter is to get the exploitation surface for an attacker. Kube-Bench is more like a configurations or the CIS benchmarking tool that we use for the auditing purpose. So it supports frameworks like SOC 2, PCI, HIPAA, and let's download its manifest. So it is the same process. We'll download the manifest, create a namespace, and deploy that particular job. So this is done. Next, I will check its output. So for that, First of all, I'll run this job, and this job is completed. Now we'll see the logs. So CIS benchmark for Kubernetes is divided into 5 sections. Each section I have a certain rules, and mostly it's based on the worker node configurations and the control plane configuration. So these are the all rules of each sections I have. So this is a 5th section, this is a 4th section, and similarly I have a 1st, 2nd, and 3rd section. So now if you can notice, the 2nd section is talking about the set, which is a database, key value database present on a control plane. It is checking if that certification file have the appropriate permissions, and similarly it has a role for control plane and the worker node. So we are getting the output in the form of whether this particular rule is passed, fail, or warning. So warning means you have to manually, automatically, it is not possible. So it is mainly checking the kubelet configurations, TLS setting, and RBAC flags at node level. Whereas in a control plane, it is checking more towards the API server, audit log is enabled or not, or encryption is rest is present or not. So it is more like a compliance side of it. If I want to see whether my Kubernetes cluster is compliant or not, then I will go for the Kube-Bench. So now next task, I'll compare the output of these two. Like I'll compare the output of Kube-Bench and a Kube-Hunter. So for that, first of all, I will delete all my previous pod and then rerun the job. So let me delete it. And this time I'm comparing the output in a JSON format. So to compare, the output of both should be present in a same format. So here I'm choosing a JSON format. I'll get the output of Kube-Bench and Kube-Hunter in a JSON format, and then we'll compare. So I'm creating this job for Kube-Bench, and here I have specifically mentioned that the report should be generated in a JSON format. And additionally, I have added a insecure configurations like host PID is true, and I want the report in a JSON format. Next, I'm creating a job for Kube-Hunter and getting the output in a JSON format. So both the files I have created. Now I will run the apply command to actually schedule that job. So let me run the Kube-Bench job once again, and next we'll check the logs of this. So I am getting so in the both the tools, whether it is a Kube-Bench or a Kube-Hunter, you have to read the logs to get the findings. So I'm reading the logs and using a JQ to get the output in a good format or a pretty format. So it is giving me information that this is a rule number, this description, that API server pod specification file ownership, it's set to root. That's how it is checking it. And the remediations. What is the remediation? That you have to use a chown root and root followed by the file name to fix this. So as of now, if you can see, the status is pass. So that's how I'm getting the Kube-Bench output. Let's see for the Kube-Hunter. Kube-Hunter output is more towards the attacker side of it. I am getting the evidence that, okay, this path, I will get the token, certificate, namespace informations. I will just directly go to the pod or exec into the pod and get my values. And also, I think I don't have to do that. It is fetching that value for me. So that is a token that this Kube-Hunter got from the service account. So it's quite detailed for the enumeration purpose. Before going to the fix, would like to discuss the few benefits for both the tools. Can be easily integrated in a CI/CD pipeline, so you do not have to run the tool manually every time. You can just integrate in a CI/CD pipeline, get a good output, whether you can store your results in an S3 bucket or your vulnerability management tool. Depends, like you can get the output in whichever way you want. Either you want in a table format, in a raw format, or in a JSON format. It depends. So now the last activity we'll fix the issues and then run the scan again to see that whether the changes that we have done or the fixes that we have done, the tool are able to identify those issues or not. So basically earlier the status was fail, now it will be pass for those particular rules. Or earlier it was coming as a finding, now it will not come. So let's see. So I'm deleting the insecure Nginx one that I have created, where I have set the run as user 0, basically running the pod with the root user. Allow privilege escalation was true. Privileged flag was set to true. /etc was mount. So everything was present in that insecure pod. I'm deleting that. And I will focus on the fix with respect to the Kube-Bench. So I'll focus on the audit logs. I'll fix the audit log section for Kube-Bench and we'll see. Why logs are critical? Because whenever there is any compliant going on like SOC 2, PCI DSS, they generally ask for these kinds of logs. That do you have a log? What is the log retention do you have? What kind of events you're storing? Can you give us the evidence? Can you share the proofs of that? So at that time, these reports and these are very, very much required. So let me fix that. So here, if you will notice, I'm fixing this particular YAML file, manifest kube API server.yaml. I'm fixing this manifest file, and what I'm adding? I'm adding that, okay, now I will do the logging, and the log path will be var log kubernetes /order.log. I'll have set the retention and the size of the file as well. So let's just verify that whether I have made the changes successfully or not. I'm reading this particular file, and yes, these settings are present. So let me also create this varlog Kubernetes file because I have added this path here. So I've added that. This chmod 755 means I'm changing it, giving the permissions. When 557 means the root can read, write, and execute. If you are aware with this 755 permission, the 7 is for root, this one is for group, and the last one is for users. So I'm just giving a permission on that Kubernetes directory. So now as I've changes the API server file, I have to restart the kubelet just to make changes or just to apply those changes. Small automation just to check that if it has successfully started or not. Okay, the API server is ready. Now I will delete the older job and apply a new one. And again, we'll do a same step that I will scan it and we'll see that job is ready. Yes, it is ready. Now I will read the logs. Now, if you will notice that these audit log path, earlier it was coming as a fail. Now I'm getting the pass for these particular settings or for these or for all these changes that I have done. So the path is also pass, max age, max backup, and max size is also I have set. So I'm getting a pass for this. So in your report, you can mention that out of, let's say, out of 80 rules or 80 checks that we have scanned, 59 or 60 or 61 are passed. So we have a this much percentage of, so we are good with the CIS score, just for an example, like you can mention. Next, we'll do for the Kube-Hunter. So we will create a new service account, but this time with the minimal permission. So earlier we have mentioned a star here in the API group resources and a verb. This time we'll minimize this. So under the API group, I'm keeping it as a allow for all. For resources, if you will notice, I have specifically specified a resource here, and that is a pod. So all the verb that I will mention will only be applicable on pod. And verbs are list and get. So basically, I can get and list the pods in KBKH lab namespace. Now I'm binding it with the service account that I have created here, which is Nginx. And next, I'm just deploying. So here I'm creating a new deployment. Earlier that was an insecure Nginx. This time I'm creating a secure Nginx. And as you will notice, I have removed all the misconfigurations present under security context. So let's delete the previous job and create a new one. So it is scanning. We have to wait a while. Okay, the job is done. Now I will read its log to see that any finding related to the insecure Nginx pod is present or not. I don't find any findings, means it is removed because I have fixed that pod. So these are the main fixes that I have done here. Removed the privileged container and the host path, that /etc that I did earlier. And also I have applied the principle of least privileges, which is I am now attaching or a binding role that has a limited permissions. Created a secure deployment. So now I'm not able to find any findings related to the insecure pod. So here I have added the entire comparison between Kube-Bench and Kube-Hunter, that when should we use which tool, why should we use that, what are the functionality of Kube-Bench and a Kube-Hunter. So you can go through it. And here I've added all the required details that you would require while implementing the Kube-Bench or Kube-Hunter in your CI/CD pipeline. So this was it in this video. I think now you have a clear picture when to use a Kube-Bench and when to use a Kube-Hunter and how to integrate them in your CI/CD pipeline. So thanks for watching this video. Please subscribe our channel. Thank you.